Okay, so this example here, before we start this example, this is a typo here, so if you guys can just fix that, that should be theta, and this should be pi. So change those to theta and pi. I don't know if it's just my printout or if your printout turned out the same, but it should say theta and pi. Okay, so I'm just going to write it up here so that's clear. Theta plus pi. So 2 theta plus pi. Okay, so when we do this graph, we want to know the vertical shift. So we're going to look for the vertical shift here. It's +1. Okay, the amplitude is we're going to look up here, so it's going to be 1.5. Okay, my phase shift and period. Well, I can see my period is to do with this horizontal compression of 2. So I'm just going to do that right now. So it's going to be pi. The phase shift, we have to be careful though, because the way it's written here, it's going to shift to the left pi and then compress by 2. That's the order that the transformation would be done in. So we don't really want that order because it's hard to keep track of that starting point. So what we're going to do is we're going to put this into the factored form. So we're going to go 1.5 cosine, and we're going to factor that 2 out. Okay. When we factor the 2, the factored form means that we have compressed this first, then shifted it to the left pi over 2. Okay, so this is much more convenient to be able to look at the factored form and to get the period and the phase shift from this. So now once it's factored, I can now establish the phase shift is negative pi over 2. Okay, so there it is. This is a much easier way to establish that phase shift. And the key is we need factored form. So I'm just going to write that out. Okay, we put that in your notes. We need factored form. That need is a strong word, but we really want that factored form. Okay, so that way we can get this phase shift. Okay, so once we've established, now we can just graph it. I'm gonna draw my axes here. Okay, there's my y-axis. I'm gonna maybe make this position here my negative pi over 2. And the reason why I put it over there is because to accommodate, so I don't squishing my graph in. I want a little bit of space to draw my graph. I know my period is going to be pi, so I need to go over pi over 2. So if I put it here, then I'm just going to squish my graph in that really small area, which I don't want to do. Okay, so my vertical shift is going to be +1, so I'm going to put my +1 here. Okay, so then I know I'm going to go up to, there's 2, 1, and let's say 3 is going to be somewhere around here. So we're going to go up 1.5 and we're going to go down 1.5 from there. I want to draw my quadrants. Okay, those are my 4 quadrants. I need to establish the position of those 4 quadrants. Halfway between here is going to be negative pi over 4. Here is going to be pi over 4. Okay, I've established my quadrants, my middle. Okay, I want to use my amplitude now to graph this. This is a cosine graph, so I'm going to start a pi here at 2.5. So I need to go 1.5 up, down to the middle. Okay, so negative 1 is going to be about here, so I'm going to need to go 1.5 down, back to the middle, back to the top. So those are my important coordinates there. And I'm going to sketch that graph in. Those are my 4-part symmetries. So there's my 4 quadrants, and there's my graph. And I forgot to do this in the other ones, but we really should label those min and max points. So that's going to be 0.5. That's going to be pi over 2, 2.5. That's going to be negative pi over 2, 2.5. Okay, and again, the middle coordinates, we should be able to locate those middle coordinates as well. So I've labeled the max and min coordinates. I want a decimal value of zeros. Okay, well, this is the last part here. Okay, I want to find the decimal values of the zeros. So that's going to be these coordinates here. So I'm going to do these in green. So these are not nice coordinates. Okay, so we're going to have to solve and ask for decimal values. So we're going to need our calculator. So how do we set this up? Well, I take the original equation. I'm going to make that original equation make the y equal to 0. So I need to solve this. So I'm going to start with 0 is equal to 1.5 cosine 2 theta plus pi over 2 plus 1. So I suppose I could just graph this and find it on Desmos, which is fine, and you can check it that way if you like, but I'm going to solve this algebraically to the most part. So I'm going to subtract 1, divide by 1.5, so I get negative 1 over 1.5 equals cosine of 2 theta plus pi over 2. Okay, and so this is going to be negative 2/3. Okay, you don't really need to simplify that, but there it is. So at this point, I'm at the step where I need to undo the cos. So I need to undo the cos with an arc cos. Okay, so some of you know that we can just undo the arc cos by saying, well, the angle theta plus pi over 2 is equal to whatever that angle is, or I can rewrite it out, or I'm going to write it out. So this is going to be the arc cos of negative 2/3. Okay, and I'm going to draw a picture of that. Negative 2/3 maybe somewhere around here. And so there are two positions. Remember, there's always two positions when I solve for arc cos. And if I take a look at my graph, yeah, there's two positions right here. Those two positions. Okay. So I'm going to put those in. I'm going to plug those in. Did I do this right? Yeah. Negative. Okay, so I'm going to solve this by plugging into my calculator. I'm going to find my calculator here. So the arc cos of negative 2/3 for my calculator. Okay, I'm getting negative this angle, 2 times theta plus pi over 2 is equal to the angle 2.30. Okay, so that's going to be theta 1. I also have to solve for theta 2. So 2 theta plus pi over 2. The theta 2 version of this, well, I need the theta 2 is going to be 2 pi minus theta 1. Okay, and I'm getting 3.98 about. Okay, 3.982. So those are my two solutions. I need to solve them. Okay, so I'm going to get theta plus pi over 2 is equal to 2.3 divided by 2. So theta is equal to 2.3 divided by 2. That's going to be 1.15 minus pi over 2. And so my angle that I'm going to get here is going to be 1.15 minus pi divided by 2. So this is going to give me an angle of negative 0.42. Okay, so if I take a look at my graph here, that position is approximately negative 0.42. Solve for the other one. 2 divided by 2. So I'm going to get theta plus pi over 2 is equal to, that's going to be 1.99 approximately, and theta is equal to 1.99 minus pi over 2, and the decimal I'm getting is positive 0.42 approximately. Okay, and which is what I see here. Yeah, it's symmetrical about the 0 on the positive and negative sides. So there they are.